question is basically on the escape velocity that has been given by VA is proportional to acceleration due to gravity raised to the power A and radius raised to the power B. Now, the question says find the values of A and B and write the expression for escape velocity. So, without even wasting much time, as we have learned from the previous videos, proportional escape velocity, VE, is directly proportional to this. So we can introduce the equal sign and introduce the constant here. Then we say G to the power A, then R to the power B. So from here, left hand side of the equation must be equal to the right hand side of the equation. This simply means, in terms of dimensions, the units, or rather the dimensions for escape velocity or velocity, must be equal to the units, or rather the dimensions on the right hand side. So from here, what we're going to do is, we know that velocity, the units for velocity are meters per second. And the physical quantity for meter, it is length, and second, it is time. So this one, it is the same as L over T. And in terms of indices, or if we express this, so if we just follow indices, we're going to have L to the power T minus 1. When it comes up, it is going to be a negative 1. So this is a 1. When it comes up, it is going to be T to the power negative 1. So this is the value for velocity. So on the left side, we can even say LT negative 1. This must give us, so we have, so the K, we can forget about the K since we are not so much interested in the constants in dimensional analysis because they add no value when we are dealing with problems of this kind. So here, what we're going to do from here, we know that acceleration due to gravity is the same as, in fact, it has the units. So acceleration has the units meters per second squared. So the physical quantity, or the dimensions, in terms of dimensions, the physical quantity for length, it is L, and for time, it is T squared. And this one can also be written as L. This one, when it comes up, it is going to be T, then this one, it is going to be a negative. Since here it is positive, here it is going to be a negative 2 from the laws of indices. So we can plug that in. We can plug that in with L, T, negative 2. Then here we have, so this must be raised to the power A. And then we have the R, which is the radius. Then here, if you want, we can even do this. And from here, what I'm going to do is, let us just try to raise the first part here. It was raised to the power B, raised to the power B. Then, since the left hand side, okay, so from here we have L, we can distribute now the powers. So we have, on the left hand side, we have LT minus 1. This must give us L. So we have the power 1 times A, we have A to the power A. Then we have T to the power, this is negative 2 times A, so negative 2A. Then we have here, we have B, or L to the power B. So from here, since this and this, the base is the same, this can also be written as L, A plus B. So it is multiplication. So when we're multiplying the same base, we simply add the powers. So A plus B, since we are multiplying L times L. So A plus B. And from here we have the T negative 2A. So this must give us L T negative 1. So from the left hand side, we have L, this is raised to the power 1, so this is the same as raised to the power 1. So L, on the left, we have, since they are the same bases, we have the same base. So L and L are the same. So we simply equate the powers. L is equal to L, meaning the power of L here, the power of L here must also be equal. So we have 1 is equal to A plus B. So we can even call this as equation number 1. And for T, we have T to the power negative 1, and here T to the power negative 2. t and t are equal, and -1 and -2a must also be equal. So here -1 is equal to -2a. So let us call this equation 2 of a. So from here we can say -2a is equal to -1. Then we divide by -2, even here by -2. So that and this will go, and we are going to have a is equal to half, or into equation 1. So we have 1 is equal to a plus b. So our b will be 1 minus a. 1 minus, so if we put the value for a here, we're going to have 1 minus half, which will give us half. So b is also 1 over 2. So therefore, a is equal to half, and b is also half. And expressing now, we now want to express it in terms of what to put these values. So we have the k, g half, then r half. So this can also be written as k. So since they have the same powers or power, so we have the gr, we can even put it in brackets, half. And this can also be written as k square root of gr, because anything raised to the power half, it is equal to the square root of that same thing. So the escape velocity is expressed like this.